Hey everyone, let's take a look at a problem from section 3.6, which is graphing quadratic functions, right? Quadratic polynomials. Okay. Here we learn how to express a quadratic in vertex form or standard form, and we learn how to graph it pretty exactly. Let's look at the basics of that. Attempt number 8. We want to rewrite f of x equals 5x squared plus 20x plus 14. We want to write that in vertex form, which is that. That'll let us know where the vertex is, and we would have a decent idea of what the graph looked like, a rough idea of where the bottom of that parabola was, right? So that's sort of the most important part of graphing a parabola. So let's take a look at how to do that. So since we want to get it in the form a times x minus h quantity squared, the first thing we're going to do is factor out that 5 from the first two terms only. Leave the plus 14 alone for now. Now, because we want to turn this stuff in the parentheses into something squared, we need to complete the square. This problem is really just an exercise in completing the square. Now remember that to complete a square, you do b over 2 quantity squared. Oops, forget that plus. Plus b over 2 quantity squared. Now remember that if you're going to add something to an expression, then you have to take it away. Don't forget to multiply by 5. Okay? So again, note that we added this term only to subtract it later. I'm going to include the 5 so you don't forget. Right. Now you might be saying, well, this is just plus 2 squared, it's plus 4, right? This value right here is just plus 4. Yes, and you can change it to plus 4, but I just want to point out that you can keep this as, let's say, 4 over 2, and that factors accordingly. Okay, so that's the benefit of not squaring out the term that you added. This I will simplify to minus 20, right? And then maybe we can simplify this whole thing a little bit more to 5 times x plus 2 quantity squared minus 6. Now this is all the problem asks us to do, but the reason that we care about this sort of thing in the first place is because it gives us a basic insight into the graph of our parabola. We know that the vertex is x equals negative 2 and y equals negative 6. Okay. The way that we know this, well, again, negative 2 is the vertex, right? That's where it's squared, right? That's where the so-called bounce is going to occur. And the minus 6, we'll just find f of negative 2. Find f of negative 2. This whole thing will become 0, and you'll be left with negative 6. Okay. So our parabola is at negative 6. Further, we know it faces upwards because, well, 5 is positive. So everything is going to be greater than or equal to negative 6. Now, if we really wanted to do a good job graphing this parabola, then we would need to find the zeros of f of x, and really that form is probably best for it. Really, we'll probably need to use the quadratic formula. We're not going to do that right now, but maybe that'd be a good exercise. In the meantime, maybe try another problem. Maybe try, I don't know, number 9. The answer's in the back of the book. See if you get the right answer.